Hi, my name is Jacob Bass from the University of New South Wales in Sydney, Australia. Today I'll be demonstrating our research into the use of software-defined networking and the home environment. The use case I'll be demonstrating today will be improving the experience of using a device on the network using a northbound API exposed by the ISP. For this experiment, we'll be using a testbed which will show a typical home environment. We'll have a television connected to an Android set-top box serving high-quality YouTube traffic, high-quality YouTube video. We'll have a computer that's set up to download a very, very large file very quickly. And we'll have a laptop communicating over Skype with a computer outside the home network. These devices are connected to a layer 2 switch. The layer 2 switch is connected to our ISP, which serves content over Ethernet. The ISP link is squeezed to 5 megabits a second, which emulates the average ADSL 2+ speed of an Australian household. So for the first experiment, I'm going to show you some Skype video running over the best effort queue of the network. At the moment, this application is running by itself. You can see the quality of the application. There's very, very little aliasing. There's very, very little smudging of the video. It all runs actually quite good quality. At the moment, this is the only application running on the network. So I'll leave this running for a couple of seconds for you to get a baseline for what a Skype call looks like. So what I'm going to do now is I'm going to start a very, very large file transfer using a download manager. And what we see is that over a very short period of time, the quality of the call degrades quite rapidly. And we start to see aliasing and dropped frames. And what we see is that Skype actually starts to drop frames initially before lowering the bitrate and lowering the codec quality, and eventually dropping almost 1 to 2 frames a second. So we'll see it taking place here. We've now dropped 2 or 3 frames every time we get a new frame. So what you can see here is the video performs very poorly. There's a lot of aliasing and a lot of dropped frames. It's degraded the codec down to half of what the codec previously was. And you can see that it's very fuzzy, almost indistinguishable. This is a very, very bad quality of experience. So we can now use the northbound API that we've developed to ensure a minimum bandwidth for the user. So we have a web portal that exposes functionality from the ISP that allows the user to slice bandwidth that's a minimum assured bandwidth for the devices on the network. So I'll show you the web portal now. Here we have a selection of devices on the network that we've already added in. We choose to slice the dad's laptop with 20% bandwidth. And we can see, in a very short period of time, the call quality will increase, and the fuzziness will be gone. It'll be a crisp, clear picture again at a high frame rate. So you can see almost immediately it starts improving and ramps back up to the original quality, which we basically see here. So this is a very, very good example of using software-defined networking to improve the quality of experience of a user inside the home network. And this is one example of a use case that we've developed here at UNSW.